Hello everyone, it's my pleasure to be here today to discuss the technologies behind Huawei's OceanStor Pacific series. There are different models for different scenarios. The model we will be talking about is the C180, which features high density and large capacity. First, let's take a look at its extraordinary storage density. While a normal 4U server can only house a maximum of 36 3.5-inch disks, the C180 uses a 5U space for up to 120 3.5-inch disks. This gives it a storage density that is 2.67 times that of a normal server, making one C180 the equivalent of 3 normal servers. The cabinet footprint decreases by 62.5% to significantly reduce the cost of space, power, cooling, and O&M. Next, let's look at its capacity. A C180 offers 2.4 petabytes of raw capacity, which is equivalent to 4,800 fully equipped P40 Pro smartphones. The C180 uses Elastic EC technology patented by Huawei for a disk utilization rate of 93%. It offers a rate that is 2.81 times higher than the 3-copy solution, while providing uncompromised performance and reliability. Hardware-software synergy stores more data at lower cost. Now, let's explore the technology behind the C180's ultimate density. There are 3 obstacles to increasing storage density. The first is fitting more disks in limited space. The second is providing those disks with adequate ventilation. And the third is creating a design for easy disk maintenance. Huawei employs an ingenious design with bidirectional drawer slide, which places disks on the top and controllers on the bottom. A flexible tank chain connects disks and controller nodes. This design enables individual disk maintenance. Plugging cables on the front and back panels makes disk swapping easy. There is a 50% reduction in slide movement, and loads are balanced between the drawer slides if the enclosure moves. The lightweight design provides more space for disks and air channels. The C180 offers 50% more space between disks and 30% better heat dissipation than comparable high-density enclosures. Its unique design improves over the normal structure of one-way slides, with a 75% lower bury center offset for maximum stability. In other words, you can place the C180 anywhere in the cabinet. High density in a 5U space makes temperature control critical. A high failure rate or even complete shutdown can easily occur if the heat from the CPUs, memory modules, and 120 disks is not properly managed. Huawei uses a carbon fiber pad for heat transfer and the heat spreading technology of a vapor chamber to improve heat dissipation by 20% and cool the CPU by 11 degrees Celsius. Huawei is the first to apply a carbon fiber pad for heat transfer in its storage system for stable low heat resistance. The pad outperforms conventional silicone grease with 10 times more thermal conductivity for immediate CPU cooling. Huawei uses a VC heat spreader with a customized structure of internal capillaries. It provides higher efficiency for heat dissipation than mainstream cooling solutions and adapts to changing air channels as users pull or push the enclosure. The dual-layer design for the air channels further improves ventilation. 10 customized fans form a wall to provide 2 air channels. One is at the top for disks in the front, and one is at the bottom for CPUs and disks in the back. The fans solve the heat dissipation problem by creating a well-ventilated channel to cool the high-density device. The C180 leverages these advanced technologies to provide twice the reliability of competing products. What gives the C180 such a large capacity? Let's take a look. The real capacity that is actually available to the user is the raw capacity minus the redundancy overhead. High storage density reduces the required number of nodes. Therefore, a conventional solution for node-level redundancy results in a large redundancy overhead. Our virtual node, or vNode, design solves this problem. It allocates the 120 disks to 8 vNodes with independent fault domains. EC redundancy between the vNodes provides high utilization without compromising reliability. Capacity utilization goes up to 92% with the initial 2-enclosure configuration, and a 3-enclosure configuration increases that to 93%. In contrast, the EC solution of peer vendors for physical nodes requires the configuration of at least 16 nodes before reaching 93% utilization, and a higher space utilization than multi-copy solutions. However, higher quantities of slices require higher computing power, resulting in a higher burden on the CPU. That's why many EC solutions have poor I/O performance in comparison to multi-copy solutions. Huawei solves this problem with innovation. It moves its EC algorithm to the CPUs of the C180s and uses a dedicated engine for EC encoding and decoding. This not only streamlines encoding and decoding, but also protects I/O performance from deterioration due to CPU contention. High density and large capacity demand higher reliability. Let's go over how the C180 delivers that reliability. Efficiency is crucial for the daily maintenance of storage systems. The C180 is designed with carrier-class reliability in mind. The passive backplane, hot swappable parts, and 24/7 seamless maintenance significantly simplify maintenance and improve system availability. Two independent nodes are integrated into each specific device so that they can individually manage 60 disks. Failure of one node causes the other to take over disks in less than a second. Data links are also switched over without interrupting ongoing services. The entire process is completed without data reconstruction to guarantee smooth service. A cluster of specific devices can tolerate the failure of up to half of all nodes to provide greater system reliability and the extended maintenance intervals that are vital to large-scale deployments. In closing, ultimate density reduces O&M costs, ultimate capacity protects investments, and ultimate reliability guarantees business continuity. The OceanStor Pacific series is truly the trusted choice for mass data with its continuing innovation in storage density, capacity, and reliability. This concludes our presentation for today. Thank you very much.